video, we're going to take a look at the practice quiz for Standard 5 on operations with polynomials. So for number 1, you're asked to multiply some polynomials together. So when we look at this problem, we see this 2 right here. Remember, the 2 means that you have to multiply x plus 4 by itself because it is squared. And then you also have the x minus 2. So now all 3 of these binomials are being multiplied together. So you have to take 2 at a time and FOIL them, and then we'll use the last binomial to multiply together and get our answer. But only 2 at a time would work to start with. So I'm just going to use the FOIL method. So let's do first times first. X times x is x squared. Outside times outside, that'd be 4x. Inside times inside is another 4x. And then last times last is 16. And then combine these two like terms in the middle, so we get x squared plus 8x plus 16. But now, you can't forget that you also have to multiply by x minus 2. So I'm going to bring that down and put it out front. So you can use the box method, or you can continue with like the distributing method, we can call it. So let's distribute the first term in the binomial, which is x, to each term in the trinomial. And I'm just going to write that over here to the right where I have a little more room. So like x times x squared would give us x cubed. Then x times 8x would give us 8x squared. And x times 16 would be 16x. And then we're going to distribute the second term in the binomial to each term in the trinomial. So let's start with negative 2 times x squared. And I'm going to write it underneath the one that already has x squared over here. Then, maybe I should draw it as I go. Negative 2 times 8x would be negative 16x. And then negative 2 times 16 would be negative 32. And then you want to add all that together. Combine like terms. So we got to bring down x cubed because it doesn't have anything that matches. We have 8x squared minus 2x squared because it's 8x squared plus negative 2x squared, whichever way you want to think about it. So we get 6x squared. 16x minus 16x would just cancel out, and then we have a negative 32 we could bring down. So then that is your final answer. So it took 2 rounds of multiplying. Just a side note, if you like to use the box method, that would have also been fine. I'm not going to work it all the way out that way. I'm just going to show you how to set it up. So you could have first multiplied the x plus 4 times x plus 4. And then when you need to multiply x minus 2 times x squared plus 8x plus 16 in that second step. So like this would be your first step. Your second step would need to be a bigger box because you have a binomial of x minus 2 times the trinomial you get from your first round of FOILing. And you would end up with the same answer if you use that method, just so you know. All right, let's move on to number 2. This one says to divide, and then is 3x plus 2 a factor of the polynomial? So first we need to divide. I noticed that we have a 3 right here, so I'm going to use long division because I think that's easier. So I don't have to divide everything by 3 first. So let's just set that up. Alright, we're not missing any powers of x, so we can just get started. So 3x times 2x squared would help us get 6x cubed. So I'll write that at the top, and then I'll multiply it by each term out front and bring it down. So I would have 2x squared times 3x, which gives me back 6x cubed. And then 2x squared times negative 2 is negative 4x squared. I always write it and then change the sign of both of those terms. And then cancel out that first term, and you're all set up to write down the rest. So we bring down negative 25 plus 4 would be negative 21x squared. And I'm just going to write the 2x and the 8 as well. And then the process starts over. So you want to think about, what could I multiply 3x by to get negative 21x squared? And that would be negative 7x. So I'm going to write it at the top. And then I'm going to multiply that by each term out front. So negative 7x times 3x would be negative 21x squared. And negative 7x times negative 2 would be 14x. Write them down and then change the sign. So I'm going to make that positive, make 14x become a negative. You're less likely to make a mistake with your signs if you do it that way. And then you're set up to bring down the correct terms that are left over. So you have 2x minus 14x is negative 12x plus 8. Now we start over again. Alright, so we got to think about, what could I multiply 3x by to get negative 12x? That would be negative 4. Then we take negative 4, multiply it by what's out front, and we're bringing it down. So I got negative 4 times 3x is negative 12x, and then negative 4 times negative 2 is positive 8. Write it down, and then change both signs, because you're subtracting both of those terms. And now what's left over is 0. So I have no remainder is what that means. Which means to answer this other question up here, so don't forget after you've divided, you got to also answer, is 3x plus 2 a factor of the polynomial? With no remainder, we say yes. 3x plus 2 is a factor. Alright, let's take a look at number 3. 3 says, find the remainder, use the factor theorem to determine whether x plus 4 is a factor of g of x. So what we're going to do is do this the easy way. Because all you need to do to answer this question is plug in x equals negative 4, which is your root from that factor. So we're going to plug it in, and that will give us the remainder. So it's like you're saying g of negative 4. So 3, and plug in negative 4 with parentheses. So I'm just plugging in negative 4 for all of my x's. Now, I would certainly just use your calculator to help with that, because that's a whole lot going on. So let's put 3 and then negative 4 to the 4th power. Let's see, plus negative 4 cubed minus 2 times negative 4 squared plus negative 4 plus 12. To keep them all in parentheses, you're going to be on the safe side, and your calculator will always treat that properly. So we get 680. That is your remainder. And then since it's not equal to 0, we would say no, x plus 4 was not a factor, because it's only a factor when your remainder is 0, which means it would come out evenly. All right, that's all we needed for that one. Number 4 says find all the zeros of x cubed minus 6x squared plus 13x minus 10, given one of the factors of the polynomial is x minus 2. So if we know this is a factor, then we know we could reduce this polynomial using x equals 2. So let's put that in our box and set up for synthetic division. So use your coefficients of your polynomial you're dividing into, your dividend, and set that up. Always leave a room for another row of numbers. Bring down the 1 to start. That's just your first term, whatever that is. Then you do 1 times 2, and you write it underneath the next number. So 1 times 2 is 2, and then you add those two together. So negative 6 plus 2 gives me negative 4. Then you multiply again, so negative 4 times 2, and write it under the 13. So negative 4 times 2 will give me negative 8. And then I add those together, so 13 plus negative 8 will give me 5. Then multiply again, so 5 times 2 is 10. And then 0 is my remainder, which it should be. It's a way to check that you're doing that right, because if it's a factor, you know in advance that you should have no remainder once you divide that out. But what's left over is now a quadratic equation. Remember, we started with a cubic equation, so now what's left is quadratic. So let's write our variables with our coefficients. So we have x squared minus 4x plus 5. And it's like there's a 1 right there in the front. Now, what is left over? We could try to factor, but there are not numbers that will multiply to give us positive 5 and add up to give us negative 4. It looks good, but it just doesn't work. We got 1 times 5 is an option, and negative 1 times negative 5 is our other option. Neither one will add up to give us negative 4. So factoring is out, and we have to use another method. So the popular choice, of course, is to use the quadratic formula. So remember, x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So all we need to do is pick out a, b, and c and fill them in and simplify. Sounds good. So let's pick out a equals 1, b equals negative 4, and c equals 5. It comes from standard quadratic form, ax squared plus bx plus c. That's where I got those from. All right, so let's get started plugging those in over here. X equals negative b, so b was negative 4, so we need to make it positive 4, plus or minus the square root of b squared, so negative 4 squared, minus 4 times a, which is 1, and c, which is 5, all divided by 2a, so 2 times 1. And from there, we just need to clean that up. So let's just clean up what's underneath that big radical. 4 plus or minus the square root of, and that would be 16 minus 20, which is negative 4. Well, then we don't leave the square root of negative 4. The negative we take out as a little I to represent some imaginary roots, and then the square root of 4 would be 2. And so we can replace the square root of negative 4 with 2i. So let's rewrite that now. 4 plus or minus 2i all over 2. And then in one last step, we need to reduce the 4, the 2, and the 2. They all divide evenly by 2. So we'd be left with 2 plus or minus I. Now, a great thing to do with this problem at the end of all that work is to identify your zeros. You know you started with a cubic equation. It had a 3 for the highest exponent. So that means you should have 3 zeros when you're finished solving everything. The first one you don't want to forget was this 2 that you started with. So that is your first 0 you had from the get-go. Now you also have these 2 you have found with the quadratic formula. So you have 2 plus I and 2 minus I. So that would be all 3 that we were looking for. So let me just clean that up a tad. And there we go. That's it for number 4. Let's look at this last question. Find all the roots of f of x. So what I would start with, because they did not give you a factor to start with. Wait a minute. I want to get Desmos. Pull that up. Let's type this in and see what we could find for our real roots, because if there are real roots, they're going to be right there on my graph. So, x to the 4th minus 4x cubed plus 7x squared minus 16x plus 12. voila, we have 2 real roots. There's one at 1 and one is at 3. So you can go right over here where it says real roots and you can write 1 and 3. You've already got 2 out of the 4 roots you're looking for. How do I know there are 4? It's because there is a highest degree of 4 in this polynomial. Now, we need to use the 1 and the 3 to help us simplify so we can figure out the other 2. So, let's put 1 in a little box and put 1, all of our coefficients. So let me show you where I'm getting that from. I got a 1 in the front, then there's a -4, then there's a 7, there's a -16, and there's a 12. All right, so we're going to use one of those roots. It doesn't matter if you start with the 1 or the 3. I'm just going to start with the 1. Bring down the first term. So I got 1, then 1 times 1 is 1. -4 plus 1 is -3. -3 times 1 is -3. 7 plus -3 is 4. 4 times 1 is 4. -16 plus 4 is -12. And -12 times 1 is -12. Now, you have just reduced that quartic polynomial to a cubic polynomial. So that's your first step, is to reduce it by 1 degree. Now you need to use your other root. So I started with 1. Now I'm going to use the 3. And I'm going to reduce it 1 more time. Alright, so you use the coefficients from your cubic function, not the original one. And you also know that you had to end up with 0 because you know that if that's a root, then like x minus 1 was a factor. So we know that should have come out evenly, which is helpful. Alright, so now we're set up to reduce it 1 more time. So I'm going to bring down the 1. 1 times 3 is 3. -3 plus 3 gives me 0. 0 times 3 is just 0. 4 plus 0 is 4. 4 times 3 is 12. And once again, we know we should end up with no remainder because we know x minus 3 is also a factor. Now, what you have left is quadratic. So you have reduced a quartic polynomial pretty quickly to something quadratic. Notice it's x squared plus 0x plus 4, and you don't really need to write the 0x. So let's just take that away and bring this over here and take a look at what we got. So we have x squared plus 4. Now that's pretty simple. We don't really need the whole quadratic formula this time. We can just solve it using the square root method. So all you have to do from here is set it equal to 0. And then you can subtract the 4. So you have x squared equals -4. And then you can take the square root. And you've got x by itself. So x will equal plus or minus, and then remember that little negative comes out as an I. So we could say this is, oops, I didn't mean to erase that, hold on. This is I square root 4, which is 2i. So x will equal plus or minus 2i. Now those are your imaginary roots. You can write them as plus or minus 2i, or you can just write them separately. It does not matter. Either way is fine, but you don't have to write both. All right, so that's it for your practice quiz.